From this part, I will use 2 videos to explain total 8 questions in homework assignment number 1. In this one, I select 4 questions, relatively hard questions. All right, so let's look at the first question, question number 5. So for this one, I want to check your understanding how well you can use a formula I give you in the binary search part. So I will give you the reference. And I want to use a different example to show you how to find the answer. The formula I'm talking about is this one. The reference, let me give you the reference here. In module 4, part B2, page 4, we derived that formula. When we do that max, right? K max, remember? So that is the worst case, the number of comparisons for the worst case. So we derived this formula. Here, I like you to use this formula to find, some interesting result. All right. So I leave this question for you for the practice, but I just show you, I work on this one to show you the usual way to use this formula to find the answer. All right, so let's look at here. You compare, here it is the floor function, right? Here we have the floor function. So we should start with that floor function. Log base 2 n. Then based on this formula, it is ceiling function log base 2 of n plus 1 minus 1. So that's the formula we should use. Now, n, this is our n. This is our n. So we plug in 4s plus 3. And so this side, 4s plus 4. 4s plus 4 minus 1. All right, so now this is a nice form. 4 times s1, right? 4 times s1. S plus 1. 4 times s plus 1. Multiplication. So this is multiplication, right? Log base 2, log multiplication. So we have a property we can use, right? Log multiplication, log base 2 4 plus, so that basic property, everyone should know it, s plus 1, right? Minus 1, all right? Then we know it is 4, it is 2, right? 2 squared, the same base. So 2, another thing is 2 inside the ceiling function, we can pull it out, right? We can pull 2 out of the ceiling function. That property we also use. S plus 1 minus 1. 2 minus 1. Now we have, so let me erase, I need more space. All right, let me simplify that. S plus 1 plus 1. Okay, all right. S plus 1 ceiling function, right? S plus 1 ceiling function, look at this. Replace n by s. S plus 1 ceiling function. So that, we apply this formula another time. 1 plus floor function s plus 1. Okay, so you have 2. Okay, all right. Floor function, is it this one? Floor function, right? 1 plus 1, 2. Yeah. So finally, you get that. Okay, yeah. So you can see, I want to use a question like this to check your algebra skills. But the key formula to use is this one. Yeah. You may need to use it twice. Yeah, for this example. Yeah. But this one should be easier than this one. Yeah. Similar, at least similar. Yeah. Yeah. After my example, I hope it is not too hard for you to solve this one. Okay? Yeah. All right. Although you can use other way. Yeah. So here I do not tell you. So it's possible. So there is another different way to solve it. Yeah. You can also find correct answer. Yeah. But here I just do not say that. Yeah. All right. Next question. Growth function. Yeah. Lowest order growth function. Yeah. Here I just point out several important things here. Yeah. One, yeah, for this part, it should be easy. Yeah, because you can ignore the minor term, then you simplify it. Right? But I like to talk about several other expressions. One I like to talk about is regarding the log of n. You need to have idea. Comparing log n function with other power function. Power function. Okay? So you need to have the sense of that. Here I want to use our module 2. Yeah, here I give you a reference. Module 2, part B.3, page 4. Page 4. Yeah. There, so you look at the example 2.B3.7. In that example, yeah, in that example, we proved log of n belongs to little o of n to the d power. D is any positive number, not necessarily integer. Yeah. Real number, positive. Yeah. That means if you use log function over n to the d power, just a positive, okay? Even a very small number, still okay, and goes to infinity, this is 0. That's the meaning, okay? So you know, here, if you compare log of n with n to some d, very small d, okay? Could be very small d. Still, it is larger eventually than that. Okay? Yeah. All right. So with that, so you can see how to deal with it. Yeah. This will be, yeah, you divide it by n. Okay? So eventually it will be greater than n over n to the d, right? You can imagine that d could be a very small number, very, very small number, okay? So that's n to some minus d. Okay, yeah. So n greater than that, between these two, somewhere between that two. Okay, so you just imagine how large is it. Yeah. So that is one. About that one, I want to give you the reference. That is example, the same place, okay? Same place. Example 2.B3.5. This example, we have this. N to the d belongs to little o of a to the nth exponential function with a greater than 1. We did that. This time, you take d large number, no matter how large it is, still little o of a to the nth. Yeah. So that means this 2 to the n, yeah, a equals 2 greater than 1. This can beat any large number d. This time we don't take small number d, we take large number d eventually. Okay, so here eventually. Okay, yeah, eventually. Right. So if you replace that, you can see even you take 100, it is okay. Okay, 2 to the n can beat n to the 100. Yeah, so can beat all of them, right? Yeah. So using this way, you do the comparisons. Yeah. So I give you 2 examples you can use related to this question. Yeah. But definitely you need to understand the concepts, the methods we used. Otherwise, even I talk here, I'll give you the information, the hint here, you couldn't understand. So what's the meaning, right? Yeah. I hope you can understand. Yeah. All right. The next question, question number 9. Here, for this question, I want to talk about one key formula. Some of you know it, but some of you probably forget that formula about logarithm, the property. Yeah. So that is a to the log base a of n equals n. This formula, if you know it. Yeah. So definitely this a should be a positive number and a cannot be 1. Yeah. If your a satisfies this condition, it is always true. Okay? Always true. Yeah. All right. Here, let me show it. Yeah. If some of you have not seen this before, you may not believe it, right? Yeah. Because the proof is very short. So I like to show you here. Yeah. Only 1 or 2 minutes we can make it. Yeah. So we just let x equals a to this logarithm. We can do it. Then we show x equals n. Yeah. That's simple. Yeah. But after we introduce a new variable, okay, then we can take logarithm both sides. Log what? Log base a. How about that? Because this is a, log base a, then this part is gone, right? So we get, with that, we get log base a of x equals this side, only the exponential part. That's log base a of n. The both sides, logarithm, the good thing is they have the same log base. Then a x equals n. X equals n. Yeah. So that is this formula. Okay? This formula. Here it is true even n, not integer, it is still true. Okay? Non-integer, it is also true. Not necessary integer. Yeah. Although here we use integer, yeah, but not necessary. Yeah. Now you can apply that formula, right? Yeah. You can apply that formula. Yeah. Very nice formula. Yeah. Yeah. All right. Apply that formula. Here, a equals 2, right? So you know, what is that? Yeah. Here, a equals root 2. So you can simplify it. Yeah. But here, things are a little different. Yeah. So you may not feel comfortable handling, simplifying these two cases, two expressions. Yeah. Here, I like to show you one. Yeah. How to get idea on this number. Yeah. Because the base is different. Here, the base is 3, the log base is e, right? Yeah. So in that case, we cannot apply the previous formula we just learned. Yeah. All right, so here, we can do conversion. When this happens, we can do conversion. We try to make the same base. How about that? Can we make the same base? Yes, we can try. Yeah. Here, let me show you how to make the same base. Yeah. All right. To make the same base, all right. Yeah. Yeah. 3. Let's look at 3. What is 3? Because we want to use base e is 3 equals 3. That's the formula we use, you know. Yeah. N equals log base a. Sorry. Yeah. A to the log base a of n, right? Here, n equals 3. A equals e. How about that? Okay. So we have this. Now we have the same base e, right? Yeah. All right. Now let's take log of n. The left-hand side, right-hand side, we take right? Yeah. Now, based on the algebra, when you do this kind of thing, multiplication, okay? E multiply n, multiplication, right? Yeah. All right. When you have that, can you write it as E log of n inside and the log, natural log of 3 outside? Can you do that? Yes, we can. Yeah. Now, same base, right? E, same base. So by that formula here, n to the natural log of 3. How about that? That's the simplified version. Okay? Can you do that? Yeah. If you can do that, you can solve this problem. Okay? The C, so I do not work on C. C is similar to B. Yeah. If you can understand everything we have done here, then you can work on C and get your expression and get your final answer. Yeah. All right. Yeah. So that's the question number 9. Yeah. All right. So the last question of this part. So I want to show you the method, give you the hint, okay? Still give you the hint. Yeah. Here, the method I like to let you practice is elimination method. Okay, so when we learn binary search, yeah. So let me give you the reference. The right, yeah. Elimination method we talk about in the binary search. Yeah, you know, module 4. Yeah, part A. Yeah, part A. Yeah, 8.1 module 4. M4A1. Okay, the binary search. There, we use the elimination method. Yeah. So here, we try to extend that idea. Yeah. All right. Okay. So first, when you have the question like this, okay, we want to simplify the question. We solve the same problem, but we want to make the question a little simpler. Right? Yeah. Here, look at this number, 172. So that number relatively big, so that may cause some of you problem. You feel, oh, such a big number, how can we handle that? Yeah. Here, the exact number there is not important. Okay? Why that number is so important, right? 172. Yeah. Because some students, you know, based on my previous experience, try to plug in some formula. Yeah. When they see a question like this, they look for everywhere, try to get some formula. Yeah. If you still in that mentality, so you feel that number is important because you need to plug in that number, right? Yeah. But here, in our thinking, logical thinking, yeah, that number is not really important in our thinking. Okay? Yeah. So that means we can replace it by a smaller number for our thinking. How about we replace it by 10? Okay? So we have a 10-element array. What is the minimum number of comparisons we need so we can find one element among top 5? Is that looks a little easier? Yeah. Top 5 in 10-element array. Is that a little easier in thinking? Yeah. All right. So we make a simpler version of this question. This means using the elimination method, we want to use the minimum number of comparisons okay, to eliminate 5 elements, right? Okay. Think about if we can eliminate 5 elements in a 10-element array. Yeah. The everyone remaining is in top 5, right? Yeah. Eliminate. So the 5 elements, they are really at the bottom 5. Yeah. So we eliminate actually the bottom 5 elements. Okay. Yeah. So the next question, how do we eliminate bottom 5 elements? Here I give you another reference. Yeah. So you go to module 1, part B. Yeah, B point what? Yeah. Part B, yeah. B we have B.3 or 4. Yeah. Yeah, whatever. Yeah, B.3 or 4. Yeah. Yeah, let me put 3 here. Yeah. Page 2. Yeah. I want you to look at the minimum problem. Find the minimum. Find the minimum problem. Okay. Find the minimum. You can treat as the elimination method. Okay. So given n element array, right? Yeah. We need to eliminate n minus 1 elements. Okay? So you look at it in this way. Eliminate, okay, n minus 1 elements. The remaining is the minimum, right? Yeah. So you use the same idea. Now we are given 10 elements. We need to eliminate 5 elements. The number different, but the idea is very similar. Can you solve it? Yeah. So using this problem to help you solve. Yeah. All right, so that's all the 4 questions for part C.3. Yeah. We have another part, C.4 left.